Hey guys, so today we are going to go ahead and take notes over isotopes and average atomic mass. So before we do that, I want y'all to go ahead and take a look at our warm-up for today. Okay, compare and contrast mass number and atomic mass. So mass number is what we've been calculating all week and as well as last week. So just take a second to think and reflect, what is mass number? And then think about atomic mass. So I've been telling you guys not to use atomic mass. It's the mass that's on your periodic table. So again, go ahead and take a few minutes to go ahead and think about the difference and the similarities between those two terms. So do we actually have the nature of these two isotopes? And then we took the percentage and we found the average of the two isotopes, and that's the value that you guys see on your periodic table. Okay, so what we're going to be doing today is learning how to calculate average atomic mass. Okay, so again, atomic mass is the weighted average of the masses of all naturally occurring isotopes. And the formula that we're going to be using today is the sum of, okay, that's what this little symbol right here is for. That's what that symbol stands for. It means the sum of. Okay, we're going to take our percent abundance of our isotope and then we're going to multiply it by the mass of the isotope. Okay, we're going to do this for each and every isotope that we have. Okay, and then after we multiply these two values of each isotope, we're going to add them all up. Okay, so go ahead and take a minute to copy this slide, and then we are going to do some sample calculations together. Alright, so let's go ahead and take a look at practice problem number 1. Okay, a certain element has two naturally occurring isotopes. Determine the atomic mass given the following data and then identify the element. So we have isotope X35 as well as isotope X37. Okay, remember X stands for our unknown isotope. Okay, they also give us the mass of each isotope as well as the percent abundance of each isotope. Now, what percent abundance means is the percent, is how much percentage they exist in nature. Okay, so if this was a real element, that would mean X35, there's 75% of that in nature. Okay, X37 on the other hand, that would mean we only have 24.47% in nature. So if you add these all up, they will always equal 100%. Alright, so now we can go ahead and start calculating since we've already analyzed our data. Okay, so remember that your formula is percent abundance times the mass of your isotope. Okay, but the crazy thing here is that we are not going to use the actual percent abundance. We are going to convert this into a decimal. Okay, so the way we convert this into a decimal is dividing by 100. So 75.53%. If we divide that by 100, we would actually get 0.7553. Okay, now if you notice, instead of dividing by 100, we can always just move our decimal place over 2 times. And you are always going to move your decimal over 2 times. Okay, so for isotope X37, our percent abundance would therefore be 0.2447. Okay, now that we've converted our percent abundance into a decimal, we're going to go ahead and plug this into our equation. So remember, our formula is going to be the sum of, okay, we're going to use our percent abundance, and we're going to multiply that by the mass of our isotope. Okay, so if we take the percent abundance of our first isotope, X35. So that's going to be 0.7553. Okay, and then we're going to multiply that by its mass. So times 34.969. Okay, so that's isotope X35. Okay, now we're going to add that to our next isotope. So X37, we're going to use our percent abundance, 0.2447, and multiply that again by our atomic mass. So 36.966. Okay, so when you calculate this in your calculator, go ahead and we'll pause the video for now. I'll let you guys do your own calculations and let's see if we get the same answers. Okay? Alright, so in your calculator, what you should have got was 26.41 for our first isotope. And for our second isotope, you should have got 9.046, which equals, when we add that together, okay, you guys should get 35.46, okay? And now, remember, this is a science class, so our numbers always have to have a unit once we're done calculating. Okay, so the average atomic mass of this unknown isotope we have is 35.46. Okay, so here's another thing I also want y'all to realize about your average atomic mass is that your final answer should be really close to whichever isotope has the larger percentage. So since isotope X35 is the more abundant isotope, our answer should be close to 35, which it is. Okay, so on your test, if you ever get a question, which of the following isotopes is more abundant, well, you're going to look at the average atomic mass, and whichever isotope is closest to that average atomic mass would mean that's the most abundant. Okay, so let's go ahead and take a look at B. So what element is this? And your hint is to compare this atomic mass to ones on the periodic table to determine its identity. So let's go ahead and take a look at the periodic table. Okay, so if you take a look at your periodic table, we're going to look for the element that has the atomic mass close to 35.46. Okay, now I'll give you guys a second to see if you guys can see it for yourselves. Okay, and our answer would actually be chlorine. Okay, so that is our unknown isotope. Alright, so for B, our answer is chlorine. Okay, alright, so let's go ahead and take a look at number 2. Okay, so again, given the following data, calculate the average atomic mass of magnesium. Okay, so show your work in calculating the average atomic mass. So, of course, the very first thing we're going to do is convert our percent abundance into decimals. So remember, you either divide by 100 or you move your decimal place over to the left 2 times. So 1, 2, 1, 2, 1, 2 for each of those percent abundance. So this in turn would be 0.7870. This would be 0.1013, and then this one would be 0.1117. Alright, so let's go ahead and plug these values into our formula. Okay, so we're going to equal our first isotope. So our first isotope, our percent abundance, was 0.7870. We're going to multiply that by its atomic mass. So 23.985. That's our first isotope, magnesium 24. Then we're going to add that to our second isotope, magnesium 25. So our percent abundance was 0.1013 times its atomic mass of 24.986. Okay, that's our second isotope. And then lastly, our third isotope, magnesium 26. Okay, its percent abundance was 0.1117, and we'll multiply that by its mass of 25.983. Okay, so again, now that we have everything plugged into our formula, we can go ahead and multiply each isotope by its percent abundance and then add those up, and then we'll see what our final answer is. Okay, so again, we're going to pause the video. I'll let you guys try to figure this out on your own, and then we'll compare our answers at the end. Okay, so if we multiplied our first isotope, the number that we should have got was 18.88, plus our second isotope came out to 2.531, and then lastly our third isotope, 2.902. Okay, now you're probably going to ask, well, Miss, do we really have to do it one by one? Well, the answer is no. If you want, you can put this whole thing into your calculator if you're confident enough with your calculator skills. Okay, but I always like to be sure, so I'm just going to multiply each isotope by itself, and then in the end add them all up. Okay, so your final answer, the average atomic mass of magnesium is 24.31 AMU. Okay, and then also, if you notice, my answers, I've been rounding them to 2 decimal places. Okay, and I want you guys to go ahead and do that for every single problem that you encounter. Just go ahead and round your final answer to 2 decimal places. Okay, and then again, we need to check our work. Is our average atomic mass, is this close to the isotope that has the largest percent abundance? So if our largest percent abundance was magnesium 24, well, that's also the average atomic mass that we got. So our answer is correct. Okay, so at this time, I want you to go ahead and turn over the page, and we do have some practice problems for you guys to solve. Okay, now your problems are set up a little bit differently this time. Okay, so if you notice, you're not given a table. You're given the percent abundance next to its isotope symbol. So instead of using the table to figure out what your atomic mass is, you are going to use the mass number given to you on each isotope symbol. Okay, so these examples right here. Okay, and of course we're still going to convert our percent abundance into a decimal. Alright, so just take a look at this example, how they figured it out, and they didn't show their work exactly like I did, like as a line continuous through. They just did it per isotope going down, and then at the end, that's when they added it all up together. Okay, so either way, you're still going to get the same answer, and then your test is also going to be multiple choice. So you're not going to have to show your work, but you should still know how to work it out correctly. Okay, so for the rest of the class period, go ahead and work on the sample problems. All right?